Thank you. It's really wonderful to be here. I'm really honoured to be speaking at the Global Innovation Field Trip again. My name is Dr. Melissa Butt from the United Kingdom, and I'm from a not-for-profit educational organisation called Discovery STEM Education. I'm just going to share my PowerPoint with you, if that's okay.
Absolutely.
Okay, can you see that?
Good. Yep.
So I'm the founder of a not-for-profit educational organisation called Discovery STEM Education, and we are based at Kelham Island Museum in Sheffield. Kelham Island Museum is a museum that's all about the history of innovation, which is very rich in our city here in Sheffield. We are the steel-making city of the UK. So we're based there, so we've got the history of innovation, and then we have our centre there where we're helping and inspiring young people and teachers to inspire the next generation of STEM enthusiasts and global collaborators. We also work very closely with Sheffield University, which is a very well-known university for outstanding robotics and engineering courses and other STEM courses as well. So quite often, teachers and students and parents ask our staff what STEM is. Is it just the subjects science, technology, engineering and mathematics? We get that question quite a lot. So our feeling and our theory about STEM is not that it's just those subjects, but the understanding of those subjects and the theory behind science, technology, engineering and maths being taught as subjects in themselves is really important to be able to do this thing called STEM, which we define as actually using their science, technology, engineering and mathematics knowledge to then solve real world problems. So the important and key thing is solving real world problems using invention and innovative thinking. So I'm going to talk to you today about two of the programs which we have developed. We've developed curriculum and then we've trained young people in these programs. We've then redesigned and changed our curriculum to make sure that it meets all of the needs of young people of different ages and abilities. And we've then gone on to train teachers and pass on and disseminate that curriculum to other teachers in the UK. So one of them is one of them is a robotics program called World Educational Robotics, and the other main program that we run is called Invent Future Global. So it's part of these are both part of bigger global programs that run across the UK. So this is just a little bit of a video clip to give you an insight into what we do with our World Educational Robotics programme, as well as training young people here and developing a curriculum that meets the needs of UK teachers and then training UK teachers. We then have global events here in our university in Sheffield, where I'm going to show you an example here where we've got children from China, Mexico and the United Kingdom all collaborating together and solving real world problems using their initiative. And they're really having to be very innovative. They're given certain tasks to solve, engineering tasks, and then they creatively solve them using their own innovative ideas for their engineering and for their coding, and they all do it in very, very different ways. Children across the whole of the world, they all do it in different ways, and you never see two groups of children doing this in the same way. So here we go. This is at the part of the university where graduates have their graduation ceremony. So this is quite an exciting place to be in Sheffield. This is the hall where many, many people have graduated.
we declare that the WER 2019 European Open has begun.
And now you'll see that as well as doing their coding and their engineering, they also stand up and practice their public speaking skills. So they have a theme each year, and this year they were talking about their personal opinions on artificial intelligence and where they think that's going in the future, and giving advice about how people should use artificial intelligence in the future. And they're being judged by PhD robotics students. The guy speaking there was the head of our Advanced Manufacturing Research Centre, the director of that, which is where the BAE and Rolls-Royce systems are based at our university in Sheffield. And this is Professor Tony Prescott, who's the head of robotics at Sheffield University. So they all feel very honoured and excited with some outstanding role models there in robotics. And this guy is one of the top PhD robotics students who was just on stage there, this one. See if we can get onto the next slide. There we go. So you can see that from World Educational Robotics programs, we use the Abilix platform. And when we started to do Invention education, we started to let children use all sorts of different kinds of equipment that we had in our centre, so Connects and Lego, and we use upcycling material and anything that they can get their hands onto that they need to use for their inventions. But quite often we found that the children who do our robotics programs during their robotics classes, who had started to do invention classes, were starting to want to take their robots apart and make new things with them. So we started to allow them to start using their Abilix platform in their invention classes as well. And we were quite surprised at where that took them and the possibilities that it opened up and the new things that it enabled them to do. So we'd never ever thought of letting them take their robotics equipment apart, which has to be in a certain way. The robot has to be in a certain way with certain task models, and they just engineered things onto the robot and did a lot of creative coding. Here, the children, we actually in the end let them just take their robots apart completely, and they started to invent all sorts of different things. So this is a group of boys who have invented a totally, it's supposed to be a combined kitchen where you've got your microwaver and your chopper and everything is all together. So the parents don't need to move around different parts of the kitchen and it doesn't take up too much space. This boy has invented something that's supposed to help people on the beach. And he started on his invention poster there as well. And we've got some children here who have invented some device to help test a motorbike, helping to test the different parts of the motorbike and to test it safe in an MOT. This is a model of some kind of swing, and it's got real working parts. So on the right hand side, this is a motor here. One of the motors that had been used in the wheels of their robots for our robotics. They've then taken it all apart and made something completely new. They've made a moving, it looks like a swing here. This girl here is using a sensor and she's using some motors as well. So she's designed something because we started to get hold of all different, when we realised that they wanted to use their robotics kit, we looked at what other things can we attach to their robotics kit to be able to use in their inventions. And this girl's got a colour sensor here. And her invention, she was trying to design something that when something moved past it, then that would then trigger the motor to move. So she's attaching her sensor there and making sure that everything works. This girl is just doing some real total freestyle engineering and letting her creativity flow there, as is one of our very youngest ever participants here, who's made a fantastic parking lot. And the amount of inventions that we've seen and the amount of possibilities that we've seen have just been really surprised us. And we even managed to continue doing our Invention and our robotics program in a practical way online when everything had to go online. So whether children did or didn't have their equipment at home, we managed to keep it very practical. The children who had their kit at home did as much practical as they could, but children who didn't have their own kit at home were still able to access all of the learning and tell us what to do and tell us what to code in order for them to still take part and do interactive coding and invention classes. But some of the most recent and exciting lessons that we started to develop started to come together with a group of children who are really keen on chemistry. So these kids are really keen and constantly asking questions about chemical research and medical chemical research. So what we've started to do is develop a program here which puts together chemistry, technology, engineering and mathematics all together in one program. So the children here, you can see they've got some test tubes, because before they got any of this other kit out, any of their engineering kit out, they did a chemistry experiment. So they were detecting a chemical in their test tubes using a colour that another chemical that changes colour according to the amount of a particular chemical that is in those test tubes. So the more of the chemical that they were looking for, in this case it was protein, they were looking for protein, the more protein that was in the test tube, the darker the blue colour of the special reagent called Biuret reagent goes when they add it together in the test tube. So they engineered something really cool here, and any chemistry teachers watching will be just to see how cool this is. They have helped us to engineer something called a spectrophotometer, which is something that usually has a sensor that will detect the colour intensity in a test tube and give a number. And if you have a known amount of test tubes with a known amount of protein in those test tubes, and then you detect the change in colour in those test tubes, you can then use that data and use that information to find out how much protein is in any sample. So you can take urine samples from patients to find out if they've got kidney disease, because we shouldn't have protein in our urine. And if we detect protein, then we can figure out what stage they might be at in kidney disease. And these kids started to do this. So this is a spectrophotometer, which is a really expensive piece of equipment that's used in research laboratories. And they have engineered it, and they've all innovated it in a very different way. So although they all were interested in being able to innovate, to engineer a spectrophotometer so that they could do these high level kinds of chemistry experiments, they've all innovated them and made them very different. You can see that none of their spectrophotometers look similar, apart from they have a sensor that's close to a test tube, and a test tube is held in place, and then they've got this interface which is giving them a reading, and then they're writing down their results on the table. So they're innovating spectrophotometers because they then wanted to do this biochemical research. So what they then did, once they got a number of test tubes with a known amount of protein in them, they then drew this graph, which is called a calibration curve. So this is where the maths is coming in. So they've done their chemistry, they've done their engineering and the innovating of their spectrophotometers, and then they've collected the data, and then they plot this thing called a calibration curve, which is where the maths now comes in. So they've had a known amount of protein in each of these 11 test tubes, and then they've found out what colour they got from those known amounts of protein in those test tubes, and they've been able to plot this. But then what the exciting part of this is that they were then able to get lots of samples, which they thought were from real human urine, but it was samples that had been made up with different amounts of protein. But in the real world and in real hospital laboratories, this is happening, and not just with protein, with all sorts of different chemicals to diagnose all different kinds of diseases. So they were doing real sort of exciting kind of research and diagnostic medical work, really. And that's how they felt. So they were then able to get any particular sample with an unknown amount of protein in, add their Biuret reagent, and then measure the colour. So an example here, let's say that they found that the colour of this test tube, the colour intensity was around 0.75. They could then use a ruler, go along to their calibration curve, go down and say, okay, that patient had 1 milligram per mil of protein in their urine. That's quite a lot. This person's probably not very well. And if they had a patient who they found had a sample that was even higher, then they could say, wow, they really are in the later stages of, they could be in the later stages of kidney disease. Or they might have got a healthy patient who only had a reading of 0.2, and they could say, oh, they didn't really have very much protein in their urine, they're probably fine. So they put together their chemistry, engineering, technology, and mathematics skills in one program, which we're now developing. And then they started to actually do some coding. So some of the children who had done lots of different kinds of inventions, where they were trying to get their invention to do various things, they did all of their coding and programming using a high-level platform. The coding platform that they've been using for their robotics, they then applied to their inventions as well. So they start off using this simple flow chart to code their inventions to do all sorts of different things, so they can be automated. After a while, when they get used to using this, then click on this big orange button that says C on it, which converts their code into C programming language. So now they're also doing really high-level coding skills here, and they're learning a high-level coding language at the same time as doing their engineering and their science and their maths. And they've recently started to convert it to Python coding now as well. So they're using 2 of the main coding languages as well. So I was really keen to speak to the guy who had developed all of this equipment that we were using for our robotics, and then started using for our invention programs as well. So I spoke to this guy, Dr. Yun, and I explained to him that all the teachers who had been on our teacher training, and our own teachers in our organisation, and children, were starting to say that for their inventions they needed a lot more sensors and a lot more extra parts to be able to do more invention than what they had for just their robotics programs. And so he listened to us, and he listened to the feedback, and we now have huge invention kits as well now, where we've got grayscale sensors, but we've also got colour sensors, infrared sensors, electromagnetic sensors, fire sensors, cameras, lights, a whole variety of different kinds of motors and cogs. 6-sided connector blocks, which are really useful as well for invention, and a whole variety of structural components as well. And we're just in the early product development phases of helping them to see what works and what doesn't work for teachers in schools to be able to use this equipment. So in our centre we do teacher training. We've trained 250 teachers in our World Educational Robotics Programme, which is an example of that is the picture that you can see on the right there. We train 15 teachers at a time. On the left hand side you will see a picture of some of our teaching team, who are they've developed a robotics program for a robot called Miro, using a coding platform called Miro Code, which is like a flow chart, which can be converted into Python. And that is a robot that's been developed at Sheffield University. And Miro Code is being developed by the team at Sheffield University, and there is actually loads and loads of Miro talk. I haven't talked about Miro because I know there's so many other Miro talks happening on the Global Innovation Field Trip this time, because there has been a Gift Miro Challenge.
Hey,
and I think
I'm sorry to interrupt. I know that I let everyone go over a little bit because we have a void coming up, but I did want to get a question in.
Go for it.
From you before we had to let you go. You know, I know for sure that the kids understand the science aspect of what they're doing, but do they understand the real world impact that what they're doing is making? I mean, they're so little, they're so young. And I mean, these are fabulous pictures. And I know that they're understanding the data aspects of it, but do they get how phenomenal they are and how impactful what they do will be?
Well, yeah, I mean, we usually start off by telling them that the university team needs help with this problem now, and they just don't have enough staff to do it. So they know that we've got you guys here. They know that we've got you experts here. Can you help us with this problem? And so, you know, they get into that role that they are a professional researcher or a professional engineer, and they get to see a lot of role models who are actually in that role as well. We have lots of PhD robotics and engineering students and other prominent role models who come into our centre as well. So we do our best to try and help them to get into that role and to understand how exciting and important what they're doing is. And the teachers who we work with as well, that we train in schools, they do the same thing as well, and we link them with a lot of the role models that we work with to help them to inspire young people to really feel like they are doing something real that could have a real impact in the world.
You do incredible work, and we're very glad that you share it with us. I think we need to start booking you for longer spots though, because you have a lot to say and we want to hear it all. So thank you so much for your time today. I really appreciate all that you do, not just for this program, but for other programs that we collaborate on too. Melissa, you're fabulous, and your program is fabulous, and Emily and all of your other instructors that help are just fabulous. And thank you so much.
Thank you. There'll be a lovely talk from Emily tomorrow about her Miro program project. Thank you very much, and thank you for another fantastic Global Innovation Fellowship. I hope the rest of it goes really, really well.
Thank you.